and this is meters, this is distance. Unfortunately, we use S, not D, but in maybe meters. I mean, these units, we don't have to stick with these units, but, okay? So, maybe we could use hours here or minutes here or whatever, but seconds and meters will be fine. So, question is, what is the speed at exactly 3 seconds? That's what he was working on. And that's what calculus is working on. Okay, it's trying to answer that question. Now, you're standing here. You're one of the guys that has to do the recording. So you watch the ball go by. It does have a particular speed exactly as you see it right there. Right? And it's not like that speed doesn't exist. Right? There is a speed, sort of, right as you see it go by. But obviously, on the other hand, right here, the speed is one thing, but if I sort of down here, it's actually moving a little bit faster, right? Okay? And if I looked a little lower, it would be actually moving a little bit faster than that, right? Okay? So, but what he wanted to know is, how can he say, what is the speed right here, or right here, right anywhere? And that seems like, oh God, what a technically, why do you have to worry about that? I'm not sure why you have to worry about it, but it turns out to be very useful. Or maybe because he did it, it became useful. But anyway, so that's the question, okay? So what is the speed right there? And that basically means, what's the slope right there? But obviously the word slope doesn't really work, right? Because slope is for lines, and this is not a line. So, it doesn't really make sense to say, what is the slope right there? Because it's not even a line, right? That's a question like saying, what color is happiness? Right? Happiness doesn't have a color, right? Right? It's you're applying one concept to it in the wrong way. I think that's called, in logic, that has something, I think they use the word like categorical error or something like that. You're using one category in the wrong way. You're using a category in the wrong way. Anyway, this is doesn't quite make sense to say what is the slope right there, because it's not even a line. Okay? But we can change the question to, instead of what is the slope of this right here, we can say, we do recognize that if you have a curve, I can talk about blue. Usually there's blue. No blue. Well. Okay. I can talk about a tangent line there. Right? That I think we can imagine. Maybe we can't talk about the slope right at this point, but we can imagine a tangent line there. Okay? And then, of course, once we have a line, we can ask what about that line? We can't ask about the slope at this point, but once we have a line, which I think we all can imagine there is a line there, then we can ask what about that line? What is it? Can't hear. No, not so advanced, just really simple. Once we have the line, what can we ask about that line? I said, we're not allowed to ask about slopes of curves, right? Does anybody know what it means to be the slope of a curve? I don't think so. I think that's like saying, what's the color of happiness? Right? That doesn't make sense. But now I have this line. What can I ask about that line? What? the slope. I can ask about the slope of this line. That's no problem. Right? So we do it in steps. We say, well, I can't ask about the slope of this curve, but I can draw the tangent line, and then I can ask about the slope of that. Okay? So that's what we'll do. We will find the tangent line, and then say the slope at this point is the slope of the tangent line. Okay, that's the idea. Okay, does this make some sense or not? You don't look too happy. Does this make sense? No? Am I just talking to myself? Okay. So, okay, now the only question left, not the only question, but the question left now is how do we find that line? How do we find a tangent line? Okay, so that doesn't sound very easy. But that's why we learned about limits. How many lectures did we spend on limits? 1 or 2? Just 1?
2.
Well, we did continuity also, right? That was that all in 1 lecture? Okay, all right, so we only spent 1 lecture on limits. But anyway, we just finished with limits. And limits are going to be able to help us to get this, the tangent line. Okay? And actually, no, limits are going to be able to give us the slope of the tangent line. Limits are going to be able to give us the slope of the tangent line. And once we get that, that's called the derivative. So the slope of the tangent line is called the derivative. Okay? Now, we did talk about the derivative already, right? So you already know how to do the derivative, but we didn't prove, you already know derivative formulas, but we didn't prove those formulas. So we're going to do that. So let's see, how do we do it? So here's what they did. Here's the whole idea. Suppose I want to know at this point, what's the slope there? Let's call this x1, or no, I think we should call it x0. Let's call that x0. So this is good. Now we're not doing the physics problem anymore. We're just bringing it back to the math. Okay, we don't care whether it's distance or whatever it is. It's just x and y. So this is called y, which is what? F of x0. Right? Everyone agree so far? Okay? So I guess we should call it y0. Okay, so how do we get the slope of the tangent line? That line. How do we do that? So I don't know, I guess somehow they figured this out. They said, okay, I can't find the slope of that red line, but I can find the slope of this line. Right? Because I have 2 points, I can find the slope. Right? If I know this point, and I know this point, then I can find the slope of that line, right? That secant line, they call it. But anyway, can find the slope of that. Okay? So this is, we'll call this, we'll call this x1. So we should call this y1 or f of x1. Okay? So what is the slope given those names? So the slope of that is just delta y over delta x. right? Which is x on the bottom, it's just x1 minus x0. On the top, it's f of x1 minus f of x0. Right? Okay. And, okay, well, but that's not the slope of the red line. Right? So I didn't get the answer yet. But that's called an approximation to the slope of the red line. Okay, so how can I get a better, then I guess somebody says, how do I get a better approximation? Yeah, you choose a closer point to x0. Right? Instead of x1 being where it is, make it closer to x0. So if I do that, let's call this the new x1. Get rid of that. Well, whatever. So this is the new x1. So here and here. So then, well, that wasn't good enough actually. Let me do it this way. Let's put it here. This is the new x1. I go here. I get that point. So now I'm doing that line. Okay? That's a better approximation to the slope of the red line. The slope of the second yellow line is a better approximation to the slope of the red line. Right? Okay, so how do I get an even better approximation? So I'll do this line. Right, this line. Right, that's going to be even better. What does that mean? That just means I'm bringing x1 in even closer. And how do I get an even better one? Bring x1 in a little bit more close, right? And now that's where the limit comes. What we're going to do is we're going to let x1 approach x0, right? Use the limit. Remember the limit? So we're going to do this, but we're going to treat x1 as something we can use a limit, So we're going to do this. We're going to do this. We're calculating this. This is the slope of those yellow lines, right? This part here is the slope of the yellow line, right? That's the same as here. So that is the slope of the yellow line. But what are we doing? Each time we're moving x1 a little bit closer to x0, right? So how do we write that in last week's lecture? When we let something... Okay, let's remember what we did last week. What did we do last week? We did problems like this. We did something like this. Didn't we do something like that? Right? Remember that? So, we did something like this, right? So that meant what? What does that mean? That means let x approach 8 and then evaluate this, right? Remember that? So, what can we do here? What do I want? I want this to get closer and closer to this, right? I don't want x to approach 8. I want this to approach this, right? Does that make sense? I don't want x to approach 8. That's what I was doing in this problem. X approaches 8. Sorry, here. That's what I was doing in this problem. That was a different problem. But we have the concept of limit. And now I just want to do, I want this to approach that. That's what we're asking. That's what we want to do. We said we want to get better approximations, and we said that that's how we do it, is we let x1 approach that. We can just write that now with the limit notation. So we write x, what did we say? x1 approaches x0. Now this is very abstract because we don't even have I just said f. I didn't tell you like f is equal to a parabola. I didn't say f is equal to a cubic function. I didn't say f is equal to the cosine function. I just said f. Right? So it's very abstract right now. But we could work it out for a particular function, like this function. Let's say, suppose we were talking specifically about this one. Okay? So, but this is general. It's for any f, like it doesn't matter, if f looks like this, or f looks like that, or whatever, this is the idea. Right? But it's pretty abstract now because it's just given for any f. But this is what we want to do, right? Okay, so let's try it out and see what we get for a specific, because what is this supposed to tell me? It's supposed to tell me the slope of the red line. Right? This is supposed to tell me the slope of the red line. So let's do it for a specific example and see what the answer is. So let's try an example for f. So what function do you want to try it for? Well, I already said that's which one I want to do, but that's what we're going to do. But if I asked you, what function do you want to try it on? Well, I'm just saying, we can try any function you want to try. Right? We could try x cubed, we could try cosine of x, we could try e to the x, we could try log of x, we could try many different things. But I think the easiest one might be x squared, or almost the easiest one. So let's do that. So let's try this. And let's try and figure out what the slope is. Now we have to mention, or let's mention a particular place where we want to find it. So let's say when x equals 3, at this point, let's say x0 is 3, and I want to know the slope right there. Okay, so I'm talking about this kind of parabola function, 3, what's the height when it's x squared? If I put in 3, I get 9 height. So I want to know the slope of this line. I mean, can you tell me what the slope of this line is? Just off the top of your head? Well, if you did what we said a couple weeks ago, you could do it, but that's cheating. So, no, we can't do that. Right? We don't know it off the top of our head, right? That's not straightforward at all. Because we don't, we only have one point there. If you had 2 points, yeah, anybody can find the slope, but they only have 1 point here. So you can't tell me the answer, or not very straightforward at all. Okay? So, but now we can do it using this idea, actually. So let's fill in all of this for this particular case. So when I say this particular case, I mean x squared. We have to specific function, and even more specific than that, at a particular place. So then we're going to get an answer. Now we could guess what the answer might be by just doing exactly what we were thinking about before, which is making like an approximation. We could take that approximation. So, I could take the point 3 and the point 4, and at 4 the height is what? 16, right? So I could say that's here. And then I could calculate the slope of that. The change in this is 4 minus 3. The change is 7. So 7 over 1. So that I could guess the slope is 7. But that's just a rough guess, right? But this hopefully will give us the exact answer. Okay? So let's try it. We just have to fill in these parts and then do a limit. Okay, so what is x0 for this problem? x0 is the first point. So what is x0? Or the first x value is 3. Okay, so let's put that in. I'll try and do it here, if we have enough space. So what is that? f of 3, that goes there, right? And on the bottom, I have minus 3, right? Did I do that right? Yeah. Okay, now the other point is not going to be fixed, right? I'm not saying, 4, right? I'm going to let that other point move. So I don't want to specify that. So I want to say, and I'm going to, usually they rename it as f of, no, anyway, I'll leave it the way it is. Okay, so this is f of 1, and this is x1. I'm sorry, f of x1, and this is x1. Right? So I filled in the parts that I could fill in. And then I have to write the limit. Limit what? As x1 goes to 3. Okay. Now I'm going to go over here. Now what are we trying to do again? Let's not get lost. Trying to find the slope of the red line. And specifically this, at this point, at 3, 9, for y equals x squared. Right? And we have gotten this far. We're not finished yet, because I want to get a number. Our guess was what? Our rough estimate was 7, I think. But I want to get a number, maybe the actual number. Okay, so what else can I do here? Well, what goes here? F of 3 is what? What is f? We're doing it for this function. So f is x squared, so 3 squared. This is 9, so I can replace this by a 9. I hope this works.